Probably should be recording that. Okay, so when I plug that in, log base 4 of 13 and hit enter, I get 1.8502 equals x minus 3. So if we want to solve for our variable x here, we're going to add 3 to both sides, and x equals 4.8502. And that would be my answer right there. So that's just kind of a warm-up. That's what we did before break. If you're still with me, just say okay quick. Okay. Hey, perfect. We got some people there. That's all I needed to know. So let's go to this first example. There's a new formula here. It's not necessarily new, but it's new in the way that you guys are going to look at it. Where'd my eraser go? I'll get rid of this. Okay. And we'll go with black here. Okay. It says, suppose you deposit $5,000 into an account that earns 1.4% compounded annually. So, interest problem. How much money we'll have in the account after 10 years? The formula we're going to use for this one is A. Oh boy, hold on a second. Oh boy. I'll have to get a pencil for this one of these days. There we go. A equals P times 1 plus or minus R to the T power. Now, a couple things here. T stands for time, and that's in years. So somebody tell me what T is going to be for this problem. 10 it is. 10 years. A is the amount you're going to have in your account after 10 years. P is the amount in your account that you're going to start with. In other words, A could be the end, your end amount. And the last thing you guys have to know about is R. R is just your rate. So what's my percentage rate? 1.4, but we're not going to put 1.4% in there. We're going to put 0.014. You got to change it to a decimal. You move your decimal twice, or just take your percent and divide it by 100. That's the easiest way to do it. So now the plus or minus thing that they're talking about here, it's real simple. Are they gaining interest or are they losing interest? Well, they're gaining interest here, so we're going to use the plus. So A, let's go to blue now. A equals your starting amount, your principal is $5,000 times 1. Oh boy, I'm kind of squeezing that in there. Let's try this. Yeah, buddy, what's up? We're just on example 1 on the worksheet. It says, suppose you deposit $5,000 into an account that earns 1.4% interest compounded annually. How much money will you have in the account after 10 years? So our amount is going to equal 5,000 because we start out with 5,000 times 1 plus it's 0.014 to the T power. So the way we're going to do this is it's going to be 5,000 times, if you add the 1 plus the 0.014, it's 1.014 to the T power. So what do we want to solve for here? Oh, hold on a second. I know what T is. Sorry about that. T is equal to 10. So you plug it into your calculator just like that, 5,000 parentheses 1.04, do the little arrow key and type in 10, and you'll have how much you have in the account after 10 years. So go ahead and try that real quick on your calculators. That'll happen. Hopefully not very often. That's okay. We're moving on. I'll ask you this: is the amount going to be over $6,000? It shouldn't be. What I get for an answer is $5,745, and if you round the cents, it should be 79 cents. So that's my answer right there. That's where you just type everything in and find out how much money you have in an account after a certain amount of time. Okay. Anybody have any questions on this one? What we did? Yep. Because they're gaining good question, because they're gaining 1.4% interest. You're accumulating money in the account. If it says it's decaying or declining by that percent, then you'd subtract the percentage rate. So either add your percentage rate or subtract your percentage rate depending on the problem. Good. Anybody else? Okay, let's do this next problem because this one we're going to have to use logs in a little bit. Okay, so we're going to use the same formula. And in this one, the question is this: how long will it take you to have 7,000 in that account? Well, it's going to be evidently more than 10 years because 10 years only gave us 5,700 something. So here's how you do it. This 7,000 is your end amount, so you're going to plug that in for A. So it's going to be 7,000 equals, well, we started out with 5,000. That's the P. It's 1 plus that 0.014. And now we're looking for T. We're trying to solve for T. Now, I want you to notice this. It's an exponent. So we're going to use logs to solve this. Now, what a lot of people will try and do is they'll try and multiply the 5,000 times the 1.014. And you can't do that because it's to the T power. So the way you're going to do this problem to start off with is this. Okay? I can't multiply 5,000 times that 1.04. So I'm going to divide both sides by 5,000. And I get exactly this, 1.4 equals, just adding these two together now in the parentheses, I get 1.014 to the T power. I guess I can put that in parentheses. So here's the deal. We're going to use logs to solve this. Okay. Can anybody tell me what my base is right now? What number is 2 a power? Yes. So this is how you set it up. Log of 1.014 of 1.4, log base 1.014 to the 1.4 equals your exponent. My exponent is T. So you're just going to type this into your calculator to come up with your answer. So go ahead and do that and see how many years it takes to get to 7,000. Now you guys are doing this on Desmos, right? Or if you can use your graphing calculator, you can also use that. Yeah, this is what I'm getting for an answer. I'm getting 24.2 years. So if they asked how many years it took, it would be more than 24 years. You'd say 25 years. It's about 24 and a quarter years. Or if you put this for an answer, I would not mark it wrong. That's right. It's 24.2 years. What's that? Well, I'm just presenting my screen right now. Otherwise, you'd see my face, which I'm sure you guys don't want. Who's fishing? Oh, let's do this next problem here, and then you guys can get off and go work somewhere else, or I'll do a few of the problems on the back with you too. Okay. Okay, AJ, you talked about the plus or minus, right? Okay. So here's the deal. We're going to use that same formula. A equals P times 1 plus or minus R to the T power. Now, P is the amount you start out with. A is the amount you end up with. R is your percentage rate, and T is your time. This is a perfect example of a problem. A species of birds is declining at a rate of 0.75% per year. So in this one, are we going to use plus rate or minus rate? Minus rate, yeah. Currently there are 200,000 birds. How many birds are there after 10 years? So they're giving us the time. They want us to find out how much they have after 10 years. So we don't have to use logs to solve for time here. We just plug everything in. So A is going to equal 200,000. It'd be 1 minus. Okay, 1 minus what? What would the decimal point be? Would it be 0.75? Okay, it's 0.0075, and my time once again is 10. So what you should be typing into your calculators now to practice this and get an answer is in parentheses, it'd be 0.9925 to the 10th power. And type it in just like that in your calculator and hit enter, and you should get an answer. So this is the answer I'm getting. I hope you guys get the same thing. I'm getting 185,496. 0.25, you could put the 0.25 in there if you want, but there's no such thing as a quarter of a bird, so it'd be 185,500 roughly. That's how many birds you'd have after 10 years. So, questions on that so far? I'll take that as a no. Let's try this second one here now. Say that again? Okay. When will the population drop below, this last question here, 125,400? Well, that's going to be my amount, my end amount. So when I'm plugging this in, we want to find, once again, time. We want to find time up here. So we're going to have to use logs to solve this. 125,000. Oh boy, I got to write better. Equals 200,000. Oops, right there. And it'd be 1 minus that point. If you change that, the percent is a 0.75, so as a decimal, it'd be 0.0075 to the t. And we want to find t here. So, A, can I multiply 200,000 times this decimal, or should I divide both sides by 200,000 first? Thank you. So, let's divide both sides by 200,000. These cancel out. I actually get 0.625 equals, now just subtracting this, that's that decimal that we have up here, 0.9925 to the t. So once again, my exponent is my variable. So that means my base is 0.9925. So if I'm going to write this as a logarithm and solve, it'd be log base what? Let's hear from the gentleman. What's my base here? Is it 0.9925 or is it 0.625? Thank you. Log base 0.9925 to the 0.625 power equals t. So just plug that into your calculator and hit enter. What do we got? 0.9925. I get this, 62.43. So a little over 62 years for the population to drop below 125,400. Okay, that's it for right now. I can, I'll probably go to the back of the worksheet and try a couple problems with you guys. What I'd like you to do